Sorry. Hey everyone, good morning. Great talk about ratios and very exciting. But today I'm going to talk about operation. So how do we do that? I'm Alex Marangone. I'm part of the storage systems team at DigitalOcean. I've been at the company for around 6.5 years. And the origination of this talk was really from feedback that Matt and Tyler got from DigitalOcean. There was a lot of people asking a lot of questions about how we operate Ceph, but also why we operate the way we do. So we're going to try to address that. The very part of it. I don't have the luxury to speak fast and very clearly, if that doesn't make sense. So I concentrated on a few use cases that I think are worth talking about. If you're interested in a specific how we operate Ceph, like the T metrics, like we set no up when we were doing log and all of that, Matt addressed it very well in his presentation at the Ceph Days in New York. It's on YouTube, you can definitely check it out as well. But we're going to go on to the why.
You have to find another god now. This god is.
I'm just gonna use that. Oh, it's because it's on the Zoom. Here you go.
I'll try it again.
Here you go.
All right, so before we talk about why we operate the way we do, let's put some context and things into perspective. Ceph at DO, it's about almost now 70 clusters, over 250 petabytes of raw data. That is not in telemetry, sorry. But you can just add it up. Sorry.
You should have told me earlier.
Over 30,000 OSDs, a bunch of drives on over 1,700 nodes, spread around the world, and all of that plus much other stuff is managed by a team of 5 people. So we can't really be in the business of, as you guess, SSHing into every machine and, oh, we have to go upgrade our cluster. That's going to take some money. So we have to automate, we have to find efficiency in operation, and we have to remove a lot of headaches. Any headache that we find needs to be removed and we need to find creative solutions. All right, so let's talk about the first headache. That was solved by containers. Containers is not a headache. I know it's a touchy subject sometimes in the community. People don't want to containerize, people want to containerize. I'm agnostic to that problem. It helped us for very specific issues, and we have not looked back. The date and time frame, again, it could be a very long time, so it's a bit fuzzy, but the spirit of what I'm talking about is accurate. We had this very early system around 6 years ago that were HTTP based, large HTTPs, very dense, around 45 drives per node, running file store, with EC, and filled at over 50%. So if you operated Ceph around that time and experimenting with this system, you know that it wasn't a recipe for a lot of stability. And so this system obviously were problematic. They would randomly look up at some point, and we didn't know why at the time. We later found out that it was XFS in reclaim stalls, but we didn't know at the time. And the goal of what for us was, let's bring this system to health one step at a time, very carefully. First step, these systems were running Ubuntu Trusty on Luminous. 6 years ago, that was already old. So first step was to upgrade them to Nautilus. Now here's the catch. Trusty does not have Nautilus packages. Let's upgrade to Bionic. Bionic did not have Luminous packages. So there were basically 2 ways for us to go about that. Either we upgrade the OS and Ceph at the same time, with all the risks that it implies. So number one, obviously we have stability issues in the cluster, so we would have some placement group going inactive for a while. The other problem with this is rebuilding an entire OS includes firmware upgrade and a bunch of other processes in the step, the steps of the process. And that means that it takes about an hour. So we would have some PG switching from recovery to backfill the system, again, file store plus PC plus a lot of data. That means that some PG would switch from recovery to backfill, which means over 24 hours to recover from that. So the maximum rate of upgrading our cluster would be once a day, which meant that we would have to upgrade for weeks, running mixed version like that. Not very comfortable with that. So instead, we decided to adopt container. Very, very easy. Very quickly in the lab, we converted one OSD, fine. Then we converted the entire local cluster to containerize. Everything went fine. We tested the performance. No significant difference, no difference at all, really. And then we upgraded to others, and it looked and felt and smelled exactly like a normal Ceph upgrade. So detaching the OS from Ceph itself has been incredibly valuable to us. We have not looked back at not containerizing it. Now, the only catch, I think, with containerization is that it changes your operations. You don't have a Ceph CLI anymore on the OS. You have nothing. You need to Docker exec into something. This is particularly problematic for DigitalOcean because of our operations. My team emits and treats documentation and maintains that documentation for alerts to a cloud operation team that operates 24/7. So what it effectively means is that if we change how we operate Ceph, my team needs to update a lot of documentation. We didn't want to do that. So instead, we embarked on a journey to make Ceph look and feel and smell exactly like it was not containerized, completely obfuscating that to any team aside from ours that need to use Ceph. That's the couple of screenshots that we have here. We have a bash script that's basically a cat of USRP in Ceph. It's a sibling, but it goes somewhere else, that's fine. And it's managed new templates. We can just add to a list whatever set binary we want on our environment, and it just runs Docker exec into a container and Ceph tools that just sends the command on over there. That's the only thing that doesn't work in an obfuscated way is when you need to do a -I or -O. But again, this is just my team doing that, like this crush tool and whatnot. So it hasn't really been an issue. The other part of making containers feel and smell exactly like Variable is just to restore the system unit file. So I didn't put the upstart. That's a bit outdated. Obviously, we started with the start. And we just exec start Docker. Exec start Docker stop. That's it. That's straightforward. And we restore all of them that exist in Ceph. We just yank them and just replace the execution start and so. We have also another script, OSD mount script. And its sole purpose is to run set volume LVM activates. So change the OSD, of course, if it doesn't be mounted. That was that simple. And since then, no issue operating Ceph, no issue upgrading. We don't have to think about the OS, if it's a set variant. We don't have any head. So incredibly valuable tools. All right, let's talk about deployments. That's another question we get a lot. Why don't you use Ceph again? Absolutely. So let's talk about that for a second. When we rewrote our deployment stack, which was around 5 years ago, obviously Ceph didn't exist. The landscape was very different of deployment tools. There were two, I believe, upstream tooling that could use containerization. Rook was just started, and it requires Kubernetes. So we brushed that aside. Of course, we do not have Kubernetes environment there. The second one was Ceph Ansible. And I back in a long time ago, I worked for Red Hat, and Ceph Ansible was not necessarily the easiest tool to use to deploy Ceph. There was a bunch of issues here and there. And with a lot of like 16 years of stepping back from the situation, then you realize why it was so difficult. Upstream, this community, you have to support everything, right? Every single type of OSD deployment, every single type of OSD, this, and so on. Every type of server, you don't have to support ARM and x86. It is an incredibly large scope. And Ansible is great at a lot of things, but when it comes to that level of complexity, it gets incredibly challenging to write good code with Ansible. Now, DigitalOcean may have a lot of OSDs, kind of, but our use cases are incredibly narrow. Everything runs pretty much exactly the same and is deployed exactly the same. There are sure some variations between some generation of hardware and whatnot, but effectively everything looks the same. In fact, we are incredibly averse to Snowflake. And what it means is that our deployment stack is incredibly simple and narrow for this use case. So the code to do it has been written 5 years ago, and it hasn't changed. We have not had anything to change. And so that's why when a new tool comes upstream and to deploy, we don't really evaluate it because everything is such that it doesn't provide a lot of value for us to change that. It works, and it's pretty fast. The other aspect that is incredibly useful to maintain for us to maintain our own deployment stack and that goes back to the narrow case, is that we can be incredibly opinionated. We can say, don't deploy the OS is not that. Don't deploy the kernel is not that. If all the drive are not of the same sizes, don't deploy, right? Something that you can absolutely not do here upstream, right? So we have this ability to be incredibly strict with our deployment, which means that again, our stack to deploy is very thin and incredibly stable. So that's the value of us using our own deployment tool. When you reach a certain scale, it becomes very valuable. You don't have to maintain external tooling and all that. And realistically, when it's that simple, it is very easy to write something very quick. Like half a day, you can write that. The last part that is important to us is deployment is one thing, but deployment is just the start of your cluster's lifecycle. You're going to have to operate that cluster. And to operate that cluster, we use, among other things, we use a lot of Ansible orchestrating with AWS, which means that since the deployment is also on Ansible, we can just leverage the same code for a lot of things. Ceph, for instance, we have one playbook for that, and it applies to everything. So we can just leverage everything. I have a screenshot here of a truncated list of playbooks that we do. So making our stack very valuable. So, all right, let's talk about operation now. Like I said, 5 people, lots of staff. We can't be in the business of, oh, we need to reboot a node. So somebody in my team gets ping and we type ping. That just doesn't work at scale. Also, we have a lot of locations around the world, so time zone wise, that would be very problematic. So our goal, and it's almost marketing, it's never going to be a true noiseless stage, but that's kind of the spirit of the goal, right? If you need to do an operation that you know you're going to do regularly, or there can be interpretation into Ceph or anything, you automate it, right? You don't just spend a lot of time automating something and running it multiple times, and we know that we have all the time the same outputs than just having to rely on individuals to do the work. So what is important? First, like I said, there is an interpretation when you run set-s. So let's say you want to review the node, you go there, set-s, and you can be the best Ceph operator in the world. You might make the mistake because you're tired or something. You might have someone junior in your team that makes a mistake. Things happen, humans. So that's part of the automation, safety. The other part of safety is that there is no way to guarantee that if I'm Alex working on machine A, no one is going to work on machine B in the same cluster. What if we both run set-s at the same time, and we both reboot the node at the same time? We're below in size, there is an availability of. So automating is also kind of a safety mechanism that we use. And the way we implement this safety mechanism to prevent two operations that can change the state of the cluster from colliding with each other and causing a potential availability outage is by leveraging Rados locks. It's available, super easy to use. Every time there is an operation that can change the state of the cluster, we grab a Rados lock. On each and every cluster, we have a uniquely named object, and its sole purpose is to be locked for operational purposes. We grab this lock, and cool feature of the Rados lock, we can put a description. So whatever operation grabs the lock says what it is, and that operationally locks the cluster. If another operation tries to grab the lock, there are 2 behaviors that we define. One, if it's a CLI tool, that's the screenshot I have here. If it's a CLI tool, it just fails and dump out the description. If it's a long-running job, such as an AWS playbook, it's just going to loop around and wait for the log to be released. That's not the spirit of our operation. We log the cluster operationally, ensure that no one does anything bad, do our work, unlock the cluster, and somebody can take it. Super important for safety. That's has allowed us to also move a lot of our daily operations to other teams. So now if someone in Singapore needs to replace a DIMM in our hardware to shut down the node, they don't have to come to us. Someone can just launch its playbook. They don't have to know Ceph. They don't have to know the node even runs Ceph. They just have to know where the node is physically, launch a playbook, and solve the DIMM and move it back. So that's, again, on a team of 5 people, incredibly important to say that. Lastly, in terms of operation, I want to talk about this. We have 30,000 of them. It would be kind of weird to not talk about them. Just like everything else, we cannot use this in the business of managing our disk manually. We have a tool internally called Storage Manager, which runs both as a service and as a CLI tool. And it handles the entire life cycle of the drive. So I have an example here of an output. I hope it's readable. Of what's called a Storm recondition. A recondition is when it destroys the OSD on the cluster, zaps the drive, and recreate the same OSD in place. So what does Storm do when you do a recondition? Well, first of all, it's going to check the firmware version on the drive. And if the firmware is outdated, at the apt point in the process, it's going to update it by itself. It's fairly important with NVMe, especially to keep up to date with the servers. Here, in this case, updated. Then it does a bunch of information. It's not really interesting. Then it does a destroy process, and when it destroy, does a zap. And then when we want to bring it back up as an OSD, then it does a few other interesting checks. One is checking the LBA format size to map it to the optimal from the vendor. I haven't seen an optimal that is not 4K, but maybe that exists. I just haven't seen it. So in that case, we have the optimal LBA format, so we move on from that. And then we create the OSD. And the last two steps that are interesting, I think, are that we set the device class to the SSD model. What we found out operating Ceph is that not all SSDs are necessarily behaving equally in the Ceph. Some benefit from specific options that some don't. So we have to have some differentiation of configuration to make sure that all the drive behave well under Ceph. And we use device classes plus centralized config to apply different plugins. And the last thing that it does that could be of interest is importing upmap entries. Because it's a destroy, what we can do is, before we destroy it, we can grab all the upmap entry that exists for this drive and just reapply them once the drive is deployed. That means that the cluster state is exactly the same before and after my operation. No changes, no surprises. One of the other things that this tool does that is not on the screenshot is the ability to diagnose failed OSD. The way we operated failed OSD has changed drastically since I've been at DO. When I first started, was the first process described here. And everyone is going to be probably very familiar with it. You have a thread that failed, you get an alert, you SSH it to the machine, and then you go on the hunt for logs, right? So you look at SetOSD log, DMSH, SmartCall. You're going to look at a bunch of different places and make a determination of we should do that with this drive. Now, apply that to DigitalOcean, it's a bit more involved because, again, we have this cloud operations team, so we send them an alert for them to look at that. But this cloud operations team are not storage engineers. So we had to make a documentation that was, as you can imagine, incredibly large, yet not exhaustive and not very clear either. So subject to interpretation and missing. So then we have to visit the alert and like, oh, tell this log file, if it looks like this, do this, and so on and so forth. Now, that worked for DigitalOcean for a while, but two things about that. One, it created a lot of interrupt in our team because the documentation wasn't good. Of course, it cannot. It's the documentation for failed drive. So we would be interrupted very regularly with this operation team, but I don't know what to do with this drive. And two, we service as a drive with our scale today at 10, 15 minutes per drive. That's someone's full-time job and not a full-time one at that. So we wanted to change that, obviously, and want to get ahead of this problem. So 4 years ago, we introduced a diagnose for failed OSD. So now you receive a failed OSD alert. You log into the machine, store and diagnose the OSD ID, and it tells you what to do with the drive. It took us a while to get it right, of course, because it's log parsing, so you have new logs coming in all the time. But it took us a bit, but we got there pretty nicely now. The only flow in the process at this stage, obviously, we still need to SSH. But the other flow is that we still required human inputs and having like human communication at some point if the drives need to be replaced. So the way it works is you create a ticket, the data center people are replacing the drive, And then a few days later, we send a signal to say, hey, this drive is ready to be redeployed. And again, it's that team that does the redeployment. It works fairly well. But sometimes a drive is missed. And the rate of that miss is probably below 1%, but below 1% at 30,000 drive, well, that adds up very quick. So we wanted to automate the process end to end. And this is how we run now. And when I say now, like it's March of this year, like now, that we just started. So it still needs to be fine-tuned. And that's been done under the leadership of Matt here and with a lot of help from Tiger. We don't have now this flow for the need for a human to redeploy the drive. So Stormman now runs at the service. It will automatically detect when the noisy goes down. It can then run the diagnosis on its own. If the drive needs to be replaced, it creates a ticket, pulls the status of the ticket regularly. On the ticket marked done, we can do whatever we want with the drive, we know it's back. And whatever we want means we can do performance testing, we can do health check, or we can also just redeploy it. The other advantage of now having all of this as a service is that we can maintain long-term stats on all the drives in our fleet to make better purchase decisions and all of that with failure rate. So the last step that we did, Stormman service, large investment that at our scale we feel is very important. So not for everyone for sure. The second one, implementing diagnose, not that complicated, painful because it's load parsing, of course, but not that complicated. Really encourage to have a look at that. All right. So like I said, a few very specific subjects I want to talk about that were relevant. You don't want to talk too much. I'm a yapper. But before I end it, I want to talk about community. So like Diane mentioned, we are in the Ceph Foundation as of December 2024. Super happy about that. And echoing the sentiment, like joining the Ceph Foundation is literally the easiest way to help the Ceph community. It's low effort. It's just a bunch of cash. So if your company has the open source project, oh, I don't know if they have, just ask. That's it. You just have to ask, and if they have, consider it. It's very easy, and it's a community that gives a lot, so it's just giving back. Absolutely, super important to events like this. Now, all that I talked about, everything that we've done since for the last 6.5 years, has brought us something very precious, and that's time, which we did not have for a while. And with that time, we want to do a lot of things. Part of that is obviously being more involved in Ceph community. I remember the last Ceph day that I went to, which was in San Diego just before the pandemic, but like January 2020 or something like that. They were like, "Oh, you should do a presentation for DigitalOcean." And I'm like, I don't have time for this. We were just swamped. That was insane. Now we have time. We can do things like that, and we want to be more involved in the community and community project. So Matt, again, has been very involved in self-performance meeting. I started to involve myself in Crimson testing, but I had to step out for another project. I'm hoping to get back to it next month in April. I have a bunch of ideas. We want to, as upstream contributor and maintainer, you feel like DigitalOcean can help on some stuff. We're happy to help and just have this discussion and see where we can help. The containerization project for Ceph build, for instance, is something that we've been using internally for years. So that's something we could help with. So happy to help and have these discussions. And yeah, we want more. So you'll see us. Finally, a couple of open source projects that Dio maintains, that my team maintains really. Ceph Exporter, Prometheus Exporter for Ceph outside of the manager. Why did we do this? I think Matt addressed it. I'm not going to go into on anything there. But the key is that we started Ceph at Dio in 2016, and there was no exporter. So that's when it was created, almost 10 years. The last tool that is really cool, in my opinion, is PG Remapper. I like, maybe that's an over, I'm from the south of Europe, so sometimes I'm overly dramatic. But I like to say that Ceph data movement is dramatic, right? So like, you add a node and you see all this stuff moving around and the backfill weight and all that. You want to remove a node from the cluster. It's the same thing. It's like, it's very dramatic. So PG Remapper removes that drama by controlling backfill rates through the upmap extension table. So I encourage you to have a look. There's a lot of options and all that. There are a bunch available, and there is talk to both sides to the manager itself, which would be really, really good. Lastly, we're looking at open sourcing more stuff. I'm not going to talk about that because I don't have the time. But at the storage node level, we have a bunch of exporters running that in us that are about the OSD and whatnot, but also the drives themselves that we can query locally. So we're looking at open sourcing that, but it's kind of built in internally with DO, so we have to do a lot of work to remove that. And that's what I have. Before I stop yapping, sorry. Plug DigitalOcean, ready to be here. Awesome. We're hiring DO.co's like jobs. My team is also hiring. We need people. So go there if you're interested, or send me an email with your resume, and I can add you in. And that's what I have. Thank you.
Great.